Example 9, finding the domain and range. We want to find the domain and range of f of x, which is equal to 2 over x plus 1. Before we work on this, we need to look at the function and identify what kind of a function is it. Well, what it does is, in a toolkit, it represents a reciprocal function. Okay? And so recall that with the reciprocal function, f of x equals 1 over x, we had to exclude 0 because we could not divide by 0, and then this is what the domain and range would look like. Now, for our example, what we want to do is we want to be able to look at the denominator and find out what that restriction is. So the denominator is x plus 1, and we're going to set it equal to 0 and solve for x. So x is going to equal -1, which means that -1 is the value that has to be excluded from the domain. So, in the domain, we can see that it's going to go from -infinity to -1 and then -1 to infinity. So if you take a look at that over here, in a domain here, we had to exclude the 0 with our union. Over here, we're excluding the -1 in our domain and getting something very similar to the toolkit function. But the number that's -1 is what we need to exclude from the domain. Now, when we get to the range, okay, now the range is similar to the reciprocal function here. So let's take a look here. Going back to the domain, we can see that we're going to go from -infinity to the value of -1 on the x-axis, and then starting again, going from -1 to +infinity. When we're talking about the range is getting closer and closer to 0, so we're starting at -infinity going to 0. We can't include the 0, and then from 0 all the way to +infinity. And therefore, there is our range.